Hey everybody, this is your video on how to count atoms, and this will be the very first important step into how we balance chemical equations, and it helps us to identify like how many of each atom take place in a chemical reaction, right? So what you can see here is you can see we have a balanced chemical equation here. It's the decomposition of water, right, H2O, giving us hydrogen gas and oxygen gas. This equation's already been balanced for us, so nothing's being created or destroyed. We'll talk about that more when we talk about the law of conservation of matter. But we've got coefficients and we've got subscripts here, and we need to use both of those things to help us understand what we're looking at and to count the number of each element here. So, what we need to do is we need to first understand what the subscript tells us, right? So we know the coefficient tells us how many of each substance we have, right? So we have, two molecules of H2O here. What H2O tells us is that we have two hydrogens for every one oxygen, right? H2O. And because we don't see a number here, we just assume it is one, okay? And so when we go to count how many hydrogens and how many oxygens are in this reactant side of our equation here, this 2H2O, what we do is we just take the coefficient and we multiply it by the subscript, and that tells us how many of each element there are. So if we were to take hydrogen, for example, and we look at how many hydrogens we have, we would do 2 times 2. So I'll do 2 times 2 here. And that tells us we're going to have 4 hydrogens, right? We have 4 hydrogens on the reactant side of our equation. If we were to do the same thing for oxygen, we take our 2 and we multiply by 1 here, right? So we do 2 times 1. And that tells us we have 2 oxygens involved, right? We have H2O. Each H2O has 2 hydrogens and 1 oxygen. So it makes sense that if we have 2 of those, we would have 4 hydrogens total and 2 oxygens total, okay? So there are some other types of compounds as well that we need to be aware of. Those are called polyatomic ions, right? So the word polyatomic means that there are many atoms in it. And an ion tells us that it is charged. Okay, so you can see some examples of these here. Some of the common names that you'll see are things like sulfite or nitrite or chlorite. The important thing is to note that NO2 minus 1, that entire thing is the polyatomic ion, right? So just like we will sometimes see Na plus, sodium will sometimes bond to a negative chloride, right? And that will happen in the same way that this Na plus will bond to the NO2 minus 1, right? So what we're doing is we're pretty much saying that a polyatomic ion can just replace a normal ion as part of our chemical formula, okay? And you're going to get more practice of that as we go along. But I just want you to be aware that sometimes these polyatomic ions will appear, and many times they will appear in parentheses. That way you know that polyatomic ion is one thing, okay? So let's get some more practice on this before you go and try some on your own, okay? So what I want you to do is I want you to take a look at this. We want to calculate how many iron atoms are shown here in 2Fe2O3. That is iron 3 oxide, okay? That is rust. We want to calculate the number of iron atoms and the number of oxygen atoms. And so I'm going to let you do that now. You will have a question to answer that, and then after you've answered that question, I'll give you the answer. Okay, so you should have spent some time calculating the number of iron atoms and the number of oxygen atoms here. So remember, we do the coefficient multiplied by the subscript for each of these. So if we wanted to do iron, we would simply do 2 times 2. Hopefully you're good enough with your multiplication tables. You know that is 4, okay? And then for oxygen, we would do 2 times 3. So we do 2 times 3, and that equals 6, okay? Something to be aware of here. When we talk about elements on the periodic table, the capital element here, the capital letter in an element, tells us it is a new element, right? So when elements have 2 letters, the first one is going to be capitalized, and the second one is going to be lowercase. There's a big difference in talking about CO, which is cobalt. That is not the same thing as talking about CaO, capital O, which is carbon monoxide. Okay, cobalt is a metal. Carbon monoxide is a poisonous, odorless, colorless gas. So those are very different things there. And it's important that we are specifying those important things by using the right cases of letters. Okay. So we've got some more practice here. Uh, we can do some of these in class together, but just with all of these, we're going to just multiply the coefficient times the subscript. Okay. So again, I will let you. I'm not going to give you a question here. I just want you to pause and try to do these, and then I'm going to write down the correct answer, and I will have those available here for you, so you can see how those are done. So pause this, take a second, answer these, and then look at the answers when you're ready. Okay, everybody, hopefully you had time to answer those questions. Now, when we look at these, you can see I've done the problems out for you. If we look at PBBR, right, we have one of these. We don't see any coefficient here. So lead bromide, we have 1. And then we have no subscripts here, so we know each of them have to be 1. So we have 1 times 1 gives us 1, and 1 times 1 gives us 1 for each of those, okay? Right here, hydrogen peroxide, H2O2. Again, we have a coefficient of 1. So 1 times 2 gives us 2 hydrogens, and then 1 times 2 gives us 2 oxygens, okay? And then this one, which might have been a little tricky for you, is sodium sulfate. We have a 1 in front of it because there's no coefficient there. 1 times 2 gives us 2 sodiums, or 2 NAs. Now, SO4, you'll see that is a polyatomic ion, right? So that's 1 S and 4 O's, right? That 4 only applies to the O, not the S, because they're 2 separate elements. So that'd be 1 times 1 gives us 1 sulfur, and 1 times 4 gives us 4 oxygens. All right, everyone. So I wanted to keep these videos at 7 minutes apiece. So the next couple minutes of this are just going to be me doing some more practice problems for you, and giving you the opportunity to do those yourself and see the answers. If you don't want to see that, you do not have to. You can go and work on your assignment and try this out on your own. If you do want to try some more practice on your own and then see me give you the answers and the methodology behind that, please feel free to keep watching. Okay, but 7 minutes is where I wanted to keep it. This is longer, but it can be longer if you want it to be or not. Okay, so let's go ahead and try these. What I want you to do is I want you to attempt these on paper on your own. Try to figure out the number of each element in these compounds using the subscripts and the coefficients. And then, so pause this video. And then after you've done that, play it again to see the answers and see how I got those numbers for you. Okay. All right, welcome back. So hopefully you were able to try these out on your own. Let's go through them, okay? So you can see 3AlCl3. So we assume there's a 1 there because it's AlCl. And so we do 3 times 1, and that gives us 3 aluminums. And then 3 times 3 gives us 3 chlorines, okay? So then we have C6H5O6, and we have 2 of those. So to determine the number of carbons, we do 2 times 6. That gives us 12. Hydrogens are 2 times 5, and that gives us 10. And then oxygens are 2 times 6, and that gives us 12 oxygens, okay? And then similar over here, CH3OH. Remember, sometimes we will write out those organic or carbon-based compounds in the long way, so that's us doing this here. Rather than writing CH4O, we write CH3OH. So that's 2 times 1 carbon gives us 2 carbons. For hydrogen, we actually see hydrogen in multiple places here, okay? So we've got 2 compounds, and then we've got hydrogen 3 right here, and then hydrogen 1 right here. So we would add those together, right? Because there are 3 plus 1 hydrogens in our compound. So that's going to be 2 times 3 plus 1, which is 4. So that gives us 8 hydrogens. And then oxygen, real simply, is just 2 times 1 gives us 2 oxygens. Okay? So those are your answers there. Then we finally have one more practice slide here, so let's look at that. Here, we use some polyatomic ions and some parentheses. And so right here, you're going to multiply the number of each element inside the parentheses by the number on the outside. So we'd have 2 times PO4 here, and here we'd have 2 times OH. So go ahead and try those, and we will look at the answers. So go try them, pause this while you do that, and then I will give you the answers when you're ready. All right, guys, welcome back. So hopefully you tried to get these answers. Now you can see here in our first example, we have 4Ba3PO42. So that is 4 barium phosphate, okay? And remember, the parentheses is going to multiply on the outside by everything on the inside. So we have Ba3P1O4, and then this whole thing in parentheses is going to be multiplied by this 2 right here. Okay, so when we do that, we're going to just, do our multiplication across to get our answer. So barium, we have 4 times 3, right? Barium is not in the parentheses, so that 2 doesn't apply to it. Barium is just going to be 4 times 3 gives us 12. For phosphorus, the P right here, we do 4 times the 1 as normal, but then since it's in the parentheses, we're going to multiply it by that 2. So we get 4 times 1 times 2, which gives us 8. And then oxygen is going to be 4 times the regular 4 here, and then times 2 because it's inside the parentheses. So we get 4 times 4 times 2, which is 16 times 2, which is 32. Over here, it's going to be pretty similar. We have a coefficient of 1, right? Because we didn't see anything there. And then we have subscripts of 1 on all of these here as well, except for the 2 outside the parentheses. So copper is just going to be 1 times 1 is 1. That's Cu here. The OH is inside the parentheses, so we multiply everything inside the parentheses by this 2 right here, right? So we take our 1 times 1 for oxygen times the 2 outside the parentheses. That gives us 2 O's. Hydrogen is the same way. 1 times the 2 here, and that gives us 2 hydrogens. So hopefully you feel a little more confident in counting your atoms, and you can complete our assignment and be ready to balance equations and to calculate molar mass later on this unit. So look forward to seeing you in class. Thanks for watching.